All right, let's take a look at these 4 problems from that homework from chapter 7.2a. Now, you said you were good at getting the bases to be the same. So when we do that, the left side's going to stay as 3 to the 5x, but we could rewrite that 27 as a power of 3. And then this power would stay as 2x minus 4. 27 is not going to be 3 to the 9th power, it's 3 times 9, but instead it's going to be 3 to the 3rd power. Right? So you have to write that as a power, not just as a product. Once we have those two bases the same, then we can take a look at the powers. So I got 3 to the 5x, and over here my base is going to be 3, and when I go power to a power, we have to multiply those two together. So that's going to make a new power of 6x minus 12. So we have these two exponents where the bases are the same. The exponents are equal to each other. The bases are equal to each other. That means that the two powers have to be equal to each other. That 5x and 6x minus 12, those two have to be equal. So I'm going to write this new equation of 5x equals 6x minus 12, and then solve it from there. I'll subtract 5x to get rid of this, and also add 12 to get rid of this. So we'll have 12 is equal to x. Now you can check that answer to be sure, and all we have to do is plug 12 in for x on both sides of the equation. So if we had 3 to the 5 times 12, that's going to be 3 to the 60th power, which is huge. And you type it into your calculator, it'll give you like 4.23 E28. So we do that also to the other side of the equation, the 27 to the 2 times 12 minus 4. 2 times 12 is 24. 24 minus 4 is 20. So we take 27 to the 20th power, type it in the calculator, and we get the same thing. So we know we're right. All right, so let's try that again. Our big idea is to first rewrite this equation so that we have two exponents that are equal to each other with the same base. So we take a look at the bases. On this side I got 16, on this side I got 4. And I know that 4 times 4, or 4 squared, is 16. So that's what I'm going to replace right here. 16 is 4 squared. Everything else stays the same. And now we're going to go with a power to a power, which means that when we rewrite our equation, on the right side we'll have that 4 to the y plus 1. But when we find this new power on the left, we're going to have to multiply the 2 times 2y minus 3. So that'll be 4y minus 6. Now we have a situation where one exponent is equal to the other exponent. These two exponents had the same base, so they also have to have the same power. And so we rewrite an equation using those two powers. 4y minus 6 is equal to y plus 1. From here, just solve like normal. Subtract y from both sides. Add 6 to both sides. And we'll get y is equal to 7/3. Now you might be a little nervous, so you got a fraction for an answer, but it's okay. You can have fractions for an answer. When you have a power that's a fraction, the denominator is the root, the numerator is a power, so it's a legitimate sort of answer. Of course, you can check it just like we did in the last one. Number 3 says 2 to the 6x is equal to 32 to the x minus 2. We want to get the bases the same. So I got 2 and a 32. Obviously 32 is bigger, so the left-hand side is going to stay the same. And I'm going to have to change this 32 into 2 to some power. And I'm just not sure what yet. If you're unsure what power of 2 is going to make 32, start trying them. You know that 2 squared is 4. So 2 to the 3rd has to be 4 times 2. 2 to the 4th would have to be that times 2, which is 16. 2 to the 5th would have to be that times 2, which is 32. Oh, there's our 32, which means we could rewrite 32 as 2 to the 5th power. Now we have our bases that are the same. On the left side it's going to be 2 to the 6x, and over here we have to go with power to a power, so we're going to multiply those two together, and we'll have 5x minus 10. We got two equal exponents. Their bases are the same, so their powers have to be the same. 6x has to equal 5x minus 10. And now solve. Subtract 5x, and x equals negative 10. Here's the last one. If you want to try this one on your own before I go through it, hit pause right now and do it on your own. But we're going to want to look at bases first. We want to get these bases to be the same. Obviously 49 is bigger than 7, so the 7 side is going to stay the same. But we got to take that 49 and rewrite it as a power of 7. So 49 is 7 squared. Now we'll have the bases are the same. On the left side we have power to a power, so multiply them two together and we'll get 2x plus 10. Since the bases are equal, their powers have to be equal, so we rewrite this equation as 2x plus 10 equals 8x minus 6, and solve it like normal. Subtract 2 and add 6. Divide both sides by 6 and simplify the fraction. You should get 8/3. Okay. And those are the 4 problems from the homework. I hope that helped you out.